Hello, everybody, and welcome to an Evans News special, where today I'm just going to be talking about math for a little bit. So, today we are going to be talking about the Pythagorean theorem, and specifically something a little different. So, we know the classic Pythagorean theorem: a squared plus b squared equals c squared, where A and B are the legs of a right triangle, and C is the length of the hypotenuse. Very, very fun stuff. But what if we did something a little bit different? What if we added this little leg right here? Perfect. Something funny about this leg is it's at a 90-degree angle with the hypotenuse. Very cool. Very cool. Boom. Oh, Control Z that. Now we're just going to draw that shit. It's actually at a 90-degree angle with the hypotenuse. Very cool. Very cool. Now, let's call this length right here h. And what we are going to talk about today is that this length h gives us something called the inverse Pythagorean theorem, where 1 over a squared plus 1 over b squared is equal to 1 all over h squared. This is a cool thing, this inverse Pythagorean theorem, because it lets us do some fun stuff. I recently went on a whole thing about it, where I watched a video by 3 Blue 1 Brown, where he talks about this. Basically, we're not going to get into it today, but the reason I started to learn about this was because this infinite sum, n equals 1 over n squared, is equal to pi squared all over 6, if you can believe that. And this inverse Pythagorean theorem comes in a lot with that, quite a bit. We're not going to talk about this series, though, as fun as it is. It's one of the more fun ones. We are, however, going to... How do I make it bigger? Guys, I've become a chud with when it comes to paint. Oh, this is how I do it. Beautiful. And what we're going to do is we're going to prove this inverse Pythagorean theorem with this triangle that we have made right here. So, let's look at this triangle that we have made. Within our right triangle are two new triangles, one right here and one right here. I'm low-key going to be winging this. I proved it to myself before, but kind of just came into this, so we're going to see how this goes. So, this right here is a triangle made of two right triangles. And what we can say is, I'll call this red triangle the red one, and we'll have this blue triangle over here. So this outer triangle, which I'm going to highlight in orange real quick. Oopsie daisy. has an area of, which I'm going to do orange for the area of the orange triangle, of 1/2 A times B, right? The base, which is B, and the height is A, is the area of this outer orange triangle. But this inner red triangle right here has an area of its own, where the height is this height right here, this leg that we made that we called H. So this area is equal to 1/2 H times this leg right here. This one right here, which we don't really have a name for it right now, so we're just going to call it X. This length right here, we're just going to call it X. So the area is going to be 1/2 H times X. Now, what we can also say about this blue one is that what we have right here is a triangle with an area of 1/2 times, we're going to call this again, this is just H right here. Remember, just this leg right here was H. And this is going to be a length of C minus X. Bada bing, bada boom. That's what that is. Now, what we can say is that the area of the big triangle is equal to 1/2 AB, right? But more importantly, it is the areas of the small triangles added together. So that's going to be A for the area of the red triangle plus A for the area of the blue triangle. So let's go ahead and figure this out, shall we? Now, what we can say is that, I'm going to erase some stuff before we get to the big reveal. Is that, remember, the area of our orange triangle is 1/2 AB, and this is equal to 1/2. Oops, I'm going to try and stay consistent with my color coding. Is equal to 1/2 HX plus 1/2. Sorry, guys, I said I was going to be consistent with my color coding. Plus 1/2 H times C minus X. Beautiful, beautiful, beautiful. Let me open up another Paint tab and rewrite the equation that we just made. That, I think, perfect. Orange is the main one. That 1/2, let's make that a little smaller. That 1/2 A times B is equal to 1/2 h times x plus 1/2 h times c minus x. So we're going to do some fun stuff right here. I'm going to take out alike terms. Notice how 1/2 and h are a like term in both parts of our equation. So we can take that out. So we can say that 1/2 a times b is equal to I'm just going to go ahead and use red as the general thing. 1/2 h times x plus, still trying to color code, c minus x. Now, what do we see right here? What this is x plus c minus x. So we can actually rewrite some stuff real quick to say 1/2 a times b is equal to 1/2 h times x minus x plus c. And these guys cancel each other out. So that what we can say, because another thing that's going to cancel out are these two 1/2s right here, boom and boom, is that a times b equals h times c. And what we now want to do is I'm going to divide both sides by c. So we're going to do that real quick. Divide both sides by c. And now what we can say is that AB all over C is equal to H. You might be thinking, Evan, what the heck does this mean? We're almost there. So now we know what H is equal to, that height that we made. It's AB over C. We're now going to erase some stuff. All this math that we just did. Not too bad, not too shabby. And we're now going to rewrite what we just said, just so I can be consistent with stuff. That AB all divided by C is equal to H. I'm going to erase everything down here. Now, if AB over C is equal to H, then the inverse must be true. That C divided by AB is equal to, so sorry, I was inconsistent with my color scheming there for a second. I'm going to fix that up here real quick. C divided by AB equals 1 over H. Basically, we just flipped everything. So this has to be true. And let's see what happens when we square both sides. Now, when you square something, when you square a fraction, both the numerator and the denominator get squared. So what we end up having, what this becomes, is c squared all divided by ab squared is equal to 1 squared is just 1 all over h squared. This is what we are left with. And we're almost there, because remember the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to plug in a squared plus b squared in for c squared. And what that leaves us with is a squared plus b squared. Now, whenever you're multiplying two numbers, such as down below, and squaring them, that is equal to the squares multiplied. So ab squared is equal to a squared times b squared. And all of this, again, we haven't changed anything, is equal to 1 over h squared. And now we can separate and cancel out. And what we end up getting is this. A squared divided by a squared b squared plus b squared divided by a squared b squared equals 1 over h squared. And from here, you can see some stuff that cancels. And what we end up getting is 1 over b squared plus 1 over a squared equals 1 over h squared. And none of this, the order of addition does not matter. So it doesn't really matter what order I write this in. So what we can say is that 1 over a squared plus 1 over b squared is equal to 1 over h squared. And now we have it, our inverse Pythagorean theorem. This is a pretty fun one. And remember, where h was the leg of this triangle that we made, I'll erase some stuff to make it a little nicer. But yeah, thank you all for watching this stream. I hope you all have a wonderful night and have a great rest of your day. Peace out.